All right, so we're going to continue to talk about orbital notation. You should have done orbital notation for all the elements up to and including lanthanum so far. And what we're going to be doing today is talking about what do we do after that, because in this class we're not going to be dealing with what's called the F sublevel at all. I should be wearing my shield and not face mask here. I get so used to the face mask I forget to take it off. But we'll get back to that. Before I go into that, what I want to talk about first is about tables and graphs. So on the most recent test, what I'm seeing is that a lot of people they struggle with the table, but they struggle mostly with the way to set up a graph. So I want to make sure I'm just one more time going over the headlines or the highlights of what a table is supposed to be. Okay, so a formal table, and when I say a table, I mean a formal table. Okay, if it's not a complete table, not a formal table, then it's just a chart. All right, so all tables need to have table numbers. And table numbers are numbered like this: table 1, period, followed by description. Now, if it's more than one table, then the second will be table 2. They're numbered sequentially in whatever your report is or whatever you're doing. Then you have to have two things in the description. One thing is what's in the report or what's in the table. And the second thing is, why is that important? Now, sometimes you can write one sentence that talks about both. It basically deals with both of those, okay? So it's not enough just to tell me, never make a table description, or for that matter, a figure description, a question. It should always be a statement, all right? What's in there? Why is it important, okay? Then a table needs to have column labels, okay? And if what is in the column is some kind of measurement or calculated number for which there are units of measurement, then you must put the units of measurement in parentheses. Let's see, units. Okay. And then you're going to have numbers in each of these columns, okay? So I'm not going to do the second column with the same thing. I'm just going to put some numbers in here so we can talk about a graph, okay? Let's say I've got some measurement of, I'm going to start with 15.0, and then I'm going to go to 12.3, and 11.6 and 11.0 and 10.8. Okay, so I've got these measurements. Now the units of measurement don't go in these cells. Units of measurement go up here in parentheses in the column label. Okay, so let's say here I've got 2.11, and here I've got 2.89, and then I've got 3.77, and then 4.90, and 6.01. Okay, so I've got these. Now I put this arrow here to show that you still have to have a column label and units of measurement here. Okay, and that's basically the outline of a table. Table number, description tells me what's in there, why it's important. Column labels tell me what are you measuring in this column, what not calculation you'll find, calculated numbers you'll find in that column. Sometimes your columns don't have unit numbers. Sometimes they're descriptions of something. That's okay. But if you have numbers, then the units of measurement have to go up here, not in the cells. Okay, everybody good with that? All right. When I'm making out a table, then I need to be able to figure out, well, what range do I need to cover? Let's say this is going to be my independent variable. Okay, so I know I'm starting from about almost 11, 10 something, up to 15. So on this particular paper, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spacings. So that looks like if this is about from 10 up to 5, I can make every other one of these a basic big graduation. Now, on a graph, you don't put these numbers along this axis. Okay, some people make the mistake of thinking these numbers just go on the axis. They don't. You have to know what range, where does the number start, where they end up, what is the range, and you have to have a evenly spaced number line down here. Okay, so if I wanted to make this one, let's see if I'm at 10, 11, 12, 13, that wouldn't work. So 10, 11, 12, 13, 14, that would work. So I'm going to make 10 here, and this would be 11 here, and 12, and 13, and 14, and 15. So that'd be evenly spaced out. It's a number line, not just some numbers here that I put on this axis. Okay? And then I also need to have the same thing on the vertical axis. It looks like I'm starting at about 2 and ending up a little more than 6. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2 to 6, that's about 4 each. Let's see, if I started at 2 here, let's see, 2, 1, 2, 3, 2, 4, 6, that's not spread out enough. So 2, 1, 2, 3, 4, 5, 4, 1, 2, 3, 4, 5, 6. And let's see what let's do that. Let's just go with that one. That's what you want to do is to spread everything out. You don't want everything bunched up in a corner, in any corner, or even in the middle. You want it spread out as much as you can. Now, on a graphing program on your computer, like we're using graphical analysis this year, it automatically does that. But when you're doing a graph on paper, you have to spread it out. So you have to do some thinking. How do I spread it out so my numbers are spread out in a reasonable way? Okay, I'm going to start this one at 2 here. 1, 2, 3, 4, 5. I'll make this 3, 1. Let's see, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, I may have that may not work. I probably overdid that. Well, that's okay. You know, if you make a mistake, you just go back and fix it. All right. So instead of 3 here, let's move it down 1. So I'll say 4 of these, and that'd be 3. 1, 2, 3, 4, 4. 1, 2, 3, 4, 5, and that's not going to go to 6. So I'm going to go to 3 here. Okay. So I'll tell you what. Let's just do 3 here, and 4 here, and 5 here, and 6 here. Now, that's not really spread out as much as I'd like, but given the graduations and the fact that I'm trying to, have something that's fairly easy to graph, I want to spread it out like that. Okay? You can't just throw numbers in there and hope it works out. That's not the way. That's not how you build a graph. You've actually got to figure out how to spread it out evenly. All right. So now we'll take a look at the numbers here. My first data point is at 15 on this axis, down on the horizontal axis, and 2.11. So 15 would be right on this line right here. And if this is 2, that'd be 2.5. 2.1 is here. It's almost on that dot right there. So I'm going to put it right there. Okay? And then 12.3 would be right here. And if this would be 12.2 12.1, 2, 3, 4, 5. So 12.3 is this line right here. Okay? And so we want to be at 2.89. That's almost a 3. So 2.9 would be here. So 12.3 and 2.89. Make sure I'm looking at it right. Right there. Okay. And then we got 11.6, and you can use a ruler too if you want, if it helps you. I'll do that just to show you how this works. Okay. So let's say I'm using now 11.6, so I'll find 11.6 on here. 11.6 will be this line right here. Okay. So I'm just going to put a little trace on there just to help me find it when I'm ready to do that. And then I've got 3.77. Well, 3.77, that's almost 3.8. 3.5, 6, 7, almost 8. So the intersection of those two is going to be right here. Okay. And then let's see, the next one would be 11 even, so that's on this mark here. I don't have to trace that one out. That's pretty much on there. And then 4.9 would be right on this line right here. 4.1, 2, 3, 4, 5, 6, 7, 8, 9, and 11.0. So that would be right there. Okay. And then we've got 10.8 and 6.01. So 10.8 would be this line right here. We'll just put a little trace on here to help me find it. I'm doing a light pencil mark here. You might not even be able to see it on the camera. And then 6.01, so that'd be this line. So right there. Oh, I'm sorry, 6.01 is right. Nope, 0.01 is just barely over that. 6.1 would be this line. So that's the pattern we're looking at here, okay? Those are the numbers we have. Now, you have to have, on a graph, you have to have a title. And I've told you this before, but just trying to help make sure it's as clear as possible. A graph title has to be written so that you're telling the reader what the independent and dependent variables are. And so the pattern I've given you guys to use is you write it like this: the effect of, and then you tell them what the independent variable is. Then the words on, or on the, depending on what you need. So the effect of independent variable on whatever the dependent variable is. Okay? So the effect of, and I'm just going to put independent variable as IV and the dependent variable as DV. Okay? Just for shorthand. Got it? You have to label your axes. So you have to tell me what is being measured, or what is the calculated value that's being put on here, and then you got to tell them what units go there in parentheses. And that goes for both axes too. Okay? Now, for some people on the test, they weren't doing an evenly spaced number line on the axes. They were just taking values from the table and sticking on this line. And that's not what you have to do. It has to be an evenly spaced number line. Just like number lines in math, the horizontal axis is a number line, the vertical axis is a number line. Okay? And like I said, a computer graphing program like graphical analysis does it automatically. All right. For us, though, when you're doing it by hand, then you've got to space out your number lines and space it out in a way that doesn't group all the data down in a corner somewhere. Okay. All right. Then you have to have a figure label, and like table labels, figure labels are numbered in order: figure 1, then figure 2, and figure 3. The only tricky part, I suppose it might be tricky if you're not used to doing this, is that graphs and pictures and illustrations are all figures. So if your report has graphs and pictures and illustrations, you still have to number those sequentially. So you may have a picture first, then a graph, this would be figure 2. Then after that you might have an illustration, that'd be figure 3. Okay? So make sure you're numbering them all as figures. Okay? Now for a graph, a figure label has to tell me, just like a table, what's in there, why it's important, but it also has to tell me what the pattern is. The pattern is what direction and shape does the data go in. And so that's where a best fit line or curve comes in. Well, to me, this looks like a curve. Like a curve to you? Okay. So I'm going to do my best fit curve here, just like this. Now, I was really lucky. I just sort of guessed at some numbers. This data point is just off the curve. All right? And you almost never have the data points absolutely on the curve. They're around somewhere. So you have to split the data. Okay? I was just guessing at this and thinking that some of these would be off a little bit, but they came awfully close to that curve. All right? Because I've done this a lot. So that's what you want to make sure is your curve, your best fit line or curve is a smooth curve that splits the middle of the data. It's not a connect the dots, it splits the middle of the data. That was one of the reasons for doing that first graph we did, because you're not going to get a perfect straight line for that. Okay, so you would get a chance to see how you just put in the best fit line that splits in the middle of the data. That makes sense? All right, so that's just kind of a review of the way that tables and graphs are put together. All right, anybody have any questions about that? All right, just a couple of things. There's a few things that I noticed in grading the tests, and the tests are almost done. I've just got to put the grades together. I've gone through and checked off the things that are wrong and put notes in there about what needs to be done differently. But what I haven't done is put the numbers all together to give you an actual grade. Okay? All right. So, let's talk about orbital notation now. So I want to go back and review a bit, because it's been kind of a long weekend, just to make sure we're kind of clear as much as we can be. So hydrogen and helium on the first row of the periodic table. And that means they only have electrons in the first primary energy level. So we talked about energy levels. We talked about the nucleus being here, and the energy levels are spheres. Okay? And so electrons in the first energy level are just in that major area there. Okay, now there are sublevels within that, but not in the first level. So we're going to have a couple of electrons, one for hydrogen, two for helium in that first energy level. Then the second energy level can have up to 8 electrons. Okay? E negative, lowercase letter e negative is just a symbol for an electron. Now it doesn't have to have 8, it might just have 1. But you can have up to 8, and then you can't put any more in the second level. The third energy level can have up to 18. I'm just going to do 18 E negative here, okay, rather than write out 18 different electrons, all right? Then the fourth energy level and all levels after that can have up to 32 electrons. All right, so as we do orbital notations, we're talking about the number of electrons that exist in each of these levels. So helium, for example, the first energy level is called 1, and that corresponds to the fact that it's on the first row. It's not the same thing as, but the fact that hydrogen and helium are on this first row of the periodic table it's called a period, that tells you that it has electrons only in that first energy level. The first energy level only has s electrons, s sublevel. The first level only has an s sublevel. And for helium, we've got 2 electrons, and we show those 2 electrons as an up arrow and a down arrow to indicate what their spin is. In order for 2 electrons to be in the same orbital, they have to have opposite spins. What in the world is going on here? Oh man. Okay, I'm sorry. Somebody in my Sunday school class just got put in the hospital. Okay, so that's how we did that. I don't know, one day last week. The first level. All right. So in the second level, let's just pick one atom. Say nitrogen. No, I'll go to oxygen here. Okay. So oxygen, then we're still going to have all the electrons that are in that first level. Okay. Because once you fill up a level, you're still. In fact, every subsequent atom or every subsequent element, in terms of the orbital notations, they're just building on the previous element. Okay? So oxygen's going to have 2 electrons in the s sublevel, and we know that because of the position of lithium and beryllium. These first 2 columns here make up the s sublevel region. And helium, when we're talking about s, p, d, and f sublevels, helium really belongs here on the periodic table. So hydrogen and helium and all these elements under this are all in the s sublevel. So when we get to oxygen, we've also got to have electrons in the second row here. The periodic table indicates we have the second primary level. That's this level right here. Okay? And the first sublevel you come to is always s. And we've got the 2 electrons for these 2 elements. Okay? And then we've got 1, 2, 3, 4 electrons in this p sublevel section over here. Now the p sublevels, there are 3 orbitals. And this is the second row still, so it's the second primary level still in this level right here. The first 2 electrons were 2 of these. Now the remaining 6 can go in here, 2p, okay? But we don't need 6 more. We need 1, 2, 3, 4. With orbital notation, you put 1 electron in each of these orbital boxes. This is a kind of inventory and not the actual shape of the orbitals. You made balloon models to show the actual shape. So that's 3. Here's the 4th one right here. So after you put 1 in each orbital, then you can pair up, and what tells us we have to do it that way is something called the Pauli exclusion principle. Okay? All right. This next row works exactly the same way. Then we went down to this row down here, and I want to do titanium next. Okay? So here's titanium. We're still going to have all this stuff that we had before. So 1s, 2s, 2p. Those are all going to be completely full because we went through all these elements over here before we went down to this row, then all these elements over here before we went to this row, then these elements up to here on the periodic table. Okay? So this is going to be full. I'm going to put 1 in each orbital, then go back and pair it up. And then we got to fill up the third row. Well, the third row works the same as the second. Two electrons in S, 1 electron in each of the p orbitals, then pair them up. And then I'm ready to go to the 4th row. I'm going to go down and skip the next row here because I've kind of got something over here. So 4s is the first thing we come to. That's the electrons for potassium and calcium here. Now we're getting into what's called a D sublevel. Okay? So D sublevels have 5 orbitals. Okay? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in here. And in order to get all the electrons in the D sublevel, I need to have 5 orbitals to accommodate 2 electrons each for 10. Okay? So we're going to do, but it drops down a level. So instead of it being 4D, this is 3D. So when you get to the D sublevel, it always drops back 1 level. Okay? Putting electrons in here works the same way as it worked in the P sublevel, 1 each orbital, until each orbital has 1, and then you can pair it up. There's actually an exception in there, but we don't get into the exception in the advanced level class. Okay? So for titanium, I just need 2 electrons, 1 in each orbital, and I'm done. That makes sense? All right. So then you kept, and then we went over here to the P sublevel. We started out in 4. When we started this row, we go back to 4 when we get over here. So let's do bromine. So I went from 4S to 3D, and when I got to the P sublevel, I went back to 4P. Okay? So everything's full up here. 1 electron in each of the P orbitals and pair them up then. 1 in each P orbital, go back and pair it up. Okay, now the D sublevel is going to be full. I'm over here for bromine. So this whole section here, we've gone through this whole thing, so this D sublevel section has to be completely full. 1 in each orbital, then pair it up. And then when we get to 4P, I need 1, 2, 3, 4, 5 electrons. Okay? 1, 2, 3, 1 in each orbital, and then go back and pair it up until I get to 5. Okay? All right? Then I ask you guys to work all the way down to lanthanum. All right? So I want to do lanthanum for you so you can compare your work. You should have already turned your work in. If you haven't turned your work in, then you know, I'll have to give you an alternative assignment. Okay? You can't do the same assignment if I've already shown you how to do it. You have to do it, turn it in. If it's wrong, you can fix it, or I can give you an alternative assignment to make up for it, but you can't just turn it in after I just showed it. You just can't just copy down and get a grade for it. That makes sense? I will give you an alternative if you ask me for it. Okay? So here's lanthanum. All right, so lanthanum then is in this row. That's 1, 2, 3, 4, 5, the 6th row of the periodic table. Okay? So we've got to fill up 1s, 2s and 2p, 3s and 3p, 4s, 3d, 4p, 5s, 4d, 5p, and then 6s, and here is 5d. Okay? So 1s, 2s, 2p, 3s, 3p, 4s. This is where we're going to the D sublevel section. That's 3D. We drop back 1 to do Ds. Then go back to the primary level, the 4th level, to do Ps in that row. Let's see. I'm going to need another row here. I can see already. So. Again, I went from 5S down 1 to do D. Okay, and now I'm back in the same primary level that I started with on this row right here. So that'd be 5D. And now we're in 6. So 6S. And when we get to lanthanum, we've got to be in the D sublevel section, so that's 5D. All right, everything's full up to here. Excuse me. Oops. So there are the 2 electrons for cesium and barium, and lanthanum just needs 1 electron in 5D. Okay? And so that's the orbital notation for lanthanum. Okay? All right, I said we're going to skip the F sublevel region. F sublevel regions stick in right here. So after lanthanum, we should be filling up electrons in the F sublevel. But we're not going to do F sublevels in here. If you need to do an element beyond lanthanum, we're just going to skip that. So let's do tungsten here. Let me show you how that's going to work for this class, okay? All right. Now, this is a little bit tricky. Got to pay attention here. A little bit tricky. When you get to the F sublevel region, that's going to fill up before you even put the second electron in the D sublevel here, okay? So once we get past this dark line, I want to put F in right here, but we're going to skip over that by just putting a slash in there. That makes sense? We just skip over 4F and just finish up where we need to be in the 5D sublevel. So the numbering is going to be off. Up to lanthanum, lanthanum was element number 57. If you count the number of arrows in this, you should have 57 arrows. Once we get past lanthanum, then the numbering is going to be off a little bit because we're skipping over 14 electrons down here in this P sublevel or F sublevel region. Okay, But if you need an orbital notation beyond that, you just put in a slash. Well, so I put 6s, and I need 1, 2, 3, 4. 1, 2, 3, 4. Okay, that's how we're going to deal with skipping over F, okay, if we need that. Lots of arrows, huh? You getting the writer's cramp?
A little bit.
I get that. Okay, it is kind of tough. A lot of stuff to write. All right. Now, what about those element cubes? Because there's no way you're going to fit this on an element cube, is there? Okay, and everybody's got one large element that's just, it's going to be it's going to be difficult to do it the way we've been doing the element cube. So here's what we're going to do. I'm going to show you here. I'm going to open up an element cube thing here in a second. Let's see, where are we? So when you start to put in your element cubes, and put into your element cube the orbital notation, remember you can copy these. Just click on it, edit copy, right click copy, Control C copy, either one of those three. Then you open up the box, paste it in there, and put whatever you need in there. But it still won't fit very many right here, will it? So we're going to have a shortcut for doing orbital notation that only works on an element cube. You can't use it any other time. If you turn it in on a test, quiz, or homework that way, in this shortcut, I won't count it right, okay? You'll lose all the points. And orbital notation on homework or classwork or tests, you have to show me the whole thing, okay? And each one of these boxes is worth a point. Each of these symbols down here is worth a point. That's a lot of points to leave out all of this stuff here, okay? But we're going to take a shortcut, all right? Now, the shortcut is this, and you'll figure more of this out as we go to electron configurations. Find your element and find the next lowest noble gas. Well, noble gases, when we were doing regions of the periodic table, you should know noble gases are all the elements in this last column over here. So when I say next lowest, that's by the number. So if this is 74, I count backwards. 74, 73, 72, all of these right here, then 57, 56, 55. The next lowest noble gas is xenon, 54, okay? If we were writing the orbital notation for xenon, that would be this stuff right here. That's the orbital notation for xenon. Okay? I can write it out again, but I'm showing you that's xenon. That makes sense? So the shorthand for your element cube and only for your element cube is this. We're going to write W colon and put in a bracket the symbol for that next lowest noble gas. Now for tungsten, the next lowest noble gas is xenon. But for cadmium, the next lowest noble gas is krypton. Okay, for copper, the next lowest noble gas is argon. So you got to find the next lowest noble gas. Now, up through and including neon, you can't use this shortcut. Okay? After you have any element that's bigger than neon, you can use this shortcut. That makes sense? All right. So we're going to put, since our next lowest noble gas for tungsten is xenon, we're going to put Xe in here for the symbol for xenon. And that just indicates that's taking the place of all of this. That makes sense to you? And so all we have to do is this part. So we're going to have this. Oh, I messed up. Got to take out some of those arrows. Okay. Now that'll fit on your cube. Any questions? For your electron, for your orbital notations for your cube, or for any of this orbital notation stuff? Are we good? All right. Let's do a couple of homeworks. Okay. Well, this is pretty big. We'll just do one homework. Okay. Good enough? All right. So on this row, you're going to have a slash, and on this row, you're going to have a slash when you get to F. You're going to skip over F with a slash. Okay. Let's see. Let's do americium as homework, okay? I'm going to do orbital notation for americium. All right. So that just means that's my shorthand for writing orbital notation for americium, okay? Okay. That's orbital notation. Everybody good? All right, let's talk about electron configurations now. Electron configurations are a shorter version, a condensed version of orbital notation. Electron configurations can be thought of as a condensed form of orbital notation. Electron configurations don't give you as much information as orbital notation. So when you're writing electron configurations, you have to, for yourself, infer certain things. So the fact that electrons in orbitals are one in each orbital before you pair them up, according to that Pauli exclusion principle, electron configurations doesn't show you the spin or the orbitals. Okay? Electron configurations just shows you how many electrons there are in each orbital. That's all it does. All right, you have to know the rest of it by inference. One of the reasons for doing orbital notation first is so that we can talk about spin and the fact that you have one electron in each orbital. Okay, when we start getting into bonding, we have to do, we change the shape of orbitals, okay, called hybridization. You need to have this as a kind of a background to get there. All right, so we spend a lot of time on orbital notation. Electron configuration should be fairly easy after you do that. Okay, so let's see, we did, where are we? Oh, here we go. We did helium, orbital rotation for helium this morning in our review. Okay. Here's how the electron configuration is going to work for that. We're still going to have that element symbol for helium. Instead of the 1 and the S being on the next line down, it's going to be on the same line, 1S. And we're going to count the number of electrons in that sublevel. In this case, 1, 2. And that number becomes a superscript on S. Now please hear me when I say it's a superscript. Some people will turn in on a homework and test a 2 that's the same size as the 1, and that's not right. It has to be a superscript, or I don't give you credit for it. Okay? That makes sense? The S has to be half the size of the 1. If you make it the same size, that's not right. S, P, D, and F are always lowercase letters. All right? So that's all there is to electron configuration, to an electron configuration for helium. That makes sense? It is a condensed version of this. You got that? So for oxygen, we have the 1 and the S on the same level. O is capitalized, the oxygen symbol is capitalized, so the 1 is the same size. The S is half the size to show that it's a lowercase letter. We've got 2 electrons there, so that's going to be a superscript 2. Then 2S. And then 2P. And we got 1, 2, 3, 4 electrons. We're going to put a superscript 4 there. That makes sense? All right. Following that same pattern then, I want you to take and do the electron configuration for titanium. When you get done, show your work to somebody near you and have them show you theirs. Compare notes. See if you got the same thing. Okay? And then we will, as a class, see what the correct answer is as well. Everybody got it? Okay, have you shown your work to somebody else? You can turn around and show yours either way. Y'all can throw it all 3 up if you want to. Uh-oh. You can turn the light on over here overhead. Huh? Y'all gonna show your work? Got yours done? Show your work. No, don't show it to me. Show it to each other. Compare notes. See how you did. You got the same thing? All right. You got what I got? Same thing. All right. Let's tackle lanthanum next. Okay, do the orbital notation. I mean, electron configuration for lanthanum. We've done it as orbital notation already. Now you can do lanthanum as a class. Again, the same thing. You're going to do your work. You're going to work it out. Then you're going to show it to somebody else. Compare what you have to what they have. Show your notes to somebody else. See how you did. Compare what you have. Y'all feeling pretty comfortable with this? Okay. All right, let's compare to what I have now. See if you got the same thing. We all good? Okay. Let's see. Then if we were doing tungsten here, we got to skip over that F sublevel. So we do this. Let me turn my camera a little bit, make it easier for me to write. Okay, so W, colon, always have to have the element symbol in the colon. And this is where we skipped over the F sublevel. Let me move this down when we're doing the orbital notation, okay? After 6s, we're going to put a slash in here, just like we did with orbital notation. And then we'll take, say, 5d, and there's 4 electrons there. Does that make sense? Is that all good? Y'all are the quietest group. Y'all never say anything. Y'all don't ask questions.
I have a question.
Oh, good, man. Let me write this down on my calendar. First time, yes.
So like near the end, when you have when it says 5s and 4d then 5d, why would that be 5d and not 5d?
Oh, I'm sorry. That should be a P. That's my fault. Y'all didn't catch it a while ago. So you're absolutely right. I messed up there. You got it. Good catch, man. All right. All right, are we good? Okay. So that's the electron configuration. Okay, now, I said that this shorthand version of orbital notation is only allowed for the element cube, right? There is a shorthand for electron configurations that is allowed anytime it's allowed, and it's not just on the element cube. You'll need it for the element cube because you can't fit all this in the element cube either. But this shorthand actually is allowed when you're doing orbital electron configurations. Now, on a test or homework, I may say, give me the full electron configuration, or I may say, give me, well, this is called a noble gas kernel, okay? I may say, give me a noble gas kernel electron configuration. Kernel like a kernel of corn, K-E-R-N-E, kernel, N-E-L. So if we were going to write, say, titanium using the noble gas kernel electron configuration, I'd write titanium. I'd find the next lowest noble gas on the periodic table. Titanium is here, counting backwards from 22, 21, 20, 19. The next lowest noble gas is argon. So I'd put colon, and I put argon in brackets. It has to be in brackets, not parentheses. Okay? And then I want whatever of that electron configuration that goes beyond argon. That's going to be what I'm going to make the rest of this out of. So argon's, well, let's look. Argon is in the third row on the end of the P sublevel section. So 3p6 is where argon's electron configuration stops, right there. That makes sense? So the noble gas kernel electron configuration only needs to have that part that goes beyond argon. Okay, let's make sure we're clear. Argon's right here on the periodic table. That's in the third row at the end of the 3p sublevel section. So 3p ends right here in titanium. So all this is the noble gas configuration for argon. So all I need is anything that goes beyond that. So 4s2, 3d2. Okay? So this is an example of a noble gas kernel electron configuration. And these are all examples of full electron configurations. Okay, so let's take bromine now and let you write a noble gas kernel electron configuration for bromine. Right, a noble gas kernel electron configuration for bromine. Okay. All right. Let's see. We're going to do bromine. So have y'all compared notes yet? Compare your notes there, somebody, okay? Let them see what you did. Okay. So the next lowest noble gas from bromine is also argon. Okay. So we're going to put argon here. And we're going to have 4s2. 3D is full, so that's 3D10. And 4p5. What you got? Everybody good? Thumbs up. Shake your head up and down. Let me know you're okay. You good? Okay. All right. So the neat thing. Well, let me do this first. I'm going to add to the homework. Let's, in addition to doing the orbital notation, let's also do a full electron configuration. So we're going to call that FEC, full electron configuration, not FEC, Federal Election Commission. Full electron configuration and a noble gas kernel. Okay, got that? Think you can handle that? You can handle that? Okay, good. Trying to look at the time. There's one more thing I want to cover, and I think we have time. Okay. I want to talk now about electron dot formulas. Electron dot formulas. Electron dot formulas only use the electrons that are in the highest primary energy level. Electron dot formulas only use electrons that are in the highest primary energy level. Electron dot formulas only use electrons in the highest primary energy level. All right, so if I go back to helium here, helium only has 2 electrons, and both of those are in the highest primary energy level. This 1 indicates what the highest level is because it's not a 2. So helium has 2 electrons in its highest primary level. Does that make sense? All right, here's how it works. I'm going to write the element symbol, capital letter H, lowercase e, that's clearly 1/2 the size or 1/2 the height. Okay? I want you to imagine that there's a box or a square around this. It's not an actual square. I'm just drawing it out there so you can see what I'm talking about. Imagine a square around it. Okay? And you put those 2 electrons on separate sides of that square. It doesn't matter which side. Okay? So, I hadn't even done attendance yet either. I need to do that. Just thought about it. Let's see here. Let's say I'm going to put it on the top, in the center of the top, and the center of the left side. Okay? And that's an electron dot formula for helium. Okay. Then for oxygen, the highest level is 2. This big number 2, and both the S and P, that's the highest level. Okay? So oxygen doesn't have just 1, 2, 3, 4. You can't just count the electrons in the last set of boxes. You have to count all the electrons in the highest level. So we've got 1, 2, 3, 4, 5, 6 electrons. Okay? So for oxygen, we're going to put 6 electrons in there. Kind of like we put 1 electron in each box and then come back and pair it up. We're going to put 1 electron on each of the 4 sides, and then we pair up, and it doesn't matter which side you pair up on. So that's 4, 5, 6. I could have put it on the top this side. Doesn't matter. Or the opposite sides. Doesn't matter. That makes sense? All right. So now I want you to write the electron electron dot formula for titanium. Highest primary energy level only. Highest primary energy level only electrons, okay? Yes, sir.
You said full.
Huh? I can't hear you.
You said full.
You're going to write an electron dot formula for titanium, but you're only going to, I'm just trying to remind you, only use electrons in the highest primary level, right? Okay. Everybody got it? Anybody have any questions? Ben, you got it? You got it? Okay. How many electrons in the highest primary energy level, Alonzo?
12.
12? Really? I only see 2. 4 is the highest level, right? There's only 2 there. That makes sense? You never will have more than 8. And that only applies to noble gases. So titanium only has 2. 1, 2. You've got to count only the electrons in the highest primary level. Got it? All right. So let's add to our homework then. Electron dot formulas. For americium, okay? Everybody got that? All right, now, last thing. This is where you might want to have, well, I haven't put it on Google Classroom yet, so just bear with me. I'm going to show you something. Once I find what I did with it, what happened to it? There it is. Okay. I am going to, if I can get my computer to help me out here, I'm going to put this survey on Google Classroom probably tonight. Okay? I want you guys to help me figure out how best to handle distance learning in the, we might be back in class full time in a month. I don't know. Lawrence County planned to be back in class full time, and then they had to cancel everything last night because they had an outbreak of COVID-19. So we don't know what's going to happen. But if we're face-to-face as a whole class in a month, in the meantime, I want to try to figure out, well, what's the best way to do this distance learning thing, okay? So it's a real simple multiple choice thing. I'm going to ask you to give me a first choice and a second choice, and I want to put whatever choices in here that people propose, okay? I put 3 choices in there, but you could give me feedback in advance to give other choices. There may be something else that I haven't thought about that you would want me to put on the list here, okay? Got it? So we can keep doing what we've been doing, which is mostly distance learning by watching videos, taking notes, and doing the work just like in class, only doing it by video. And where necessary, do labs at home. Please don't put things away just yet, okay? Let me finish talking about this. Give me your full attention, all right? So I would like you to give me by text. Go on Remind and text me other suggestions, okay? And I'll try to, if I can make sense out of it, because sometimes people send me things that just don't seem to make sense, and I can't figure it out, and then they don't reply when I ask them about it. And I only have a limited amount of time to try to sort all this out, but I'm going to try to put choices on here. So don't fill out this form until, maybe we need to wait till tomorrow when I have everybody's, all the sections and all the groups, okay? So just what you need to know here is this, and I put this at the top, okay, that once I make a decision based on this feedback, I may decide not to change anything at all on Thursday, okay, just because it's too much. Or I may decide, okay, we'll try Thursday doing it this new way, maybe. So you need to pay attention. Make sure you're signed up for Remind. Make sure you're watching your email. Make sure you're paying attention to what's on Google Classroom. Once I decide what we're going to try, we may try something different. Does that make sense? So the choices I've thought about here so far is continue doing what we're doing. If you're comfortable with that, we can keep doing that. I could do where you're here today, but tomorrow you're at home, but you could be in class by doing Google Meet with the classes here. That's called the second thing here, virtual classes for the days you're home. So we're all doing the same thing at the same time, but on the days you're not here, distance learning, you're joining by Google Meet. There is a way to join Google Meet by phone, but I don't recommend that if you can help it, as long as you have internet, because you can't see what I'm talking about. You can only hear what I'm talking about if you're using a phone. Does that make sense? When you're using, got that? Okay. If we're doing it by internet, even if you turn your camera off, you can still see what I'm showing on the camera. Okay. I could do everything, instructions on paper, in which you have to read and understand the instructions and still do basically the same thing without any visual instruction. That makes sense? Now, there's only one of me and only so much time, so I can't do all these for everybody, but we'll see what everybody thinks. Got it? Everybody got that? Okay. Do you understand what I'm asking you to do? Give me feedback. Okay. Will over here gave me some feedback today. Good for you, buddy. All right. Give me some feedback. All right. Got that? All right. So tomorrow afternoon, evening, make sure you're checking back to see where this form is, okay? I'll put it on here once I get all the feedback, and we'll take whatever choices people give me to help decide what we're going to do. If I have time, it may change everything on Thursday. We'll see. Okay, that makes sense? In any event, we're still going to have a virtual class on Friday. We're going to have a Google Meet class on Friday. All good? Okay. Anybody have any feedback you can give me right now? Any thoughts you have? Too much, too soon? Got to think about it, digest it? Okay. So give me some feedback, and we'll see what we can do from there. Okay? All right. Now you can put everything away.